Hello guys, welcome to the session and I hope all of you guys are doing good. So let's get started with today's session. Today we are going to talk about RAG, that is Retrieval-Augmented Generation. You must have heard about this thing in quite various places. I am very much sure because you are joining this session. So obviously you are aware of at least the idea what it is. And if not, at least you must have heard about this term. So we'll talk about that. And we'll see one example as well. So what is RAG? Retrieval-Augmented Generation is an AI architecture that enhances large language models by combining them with external knowledge retrieval systems. Rather than solely on models' internal parameters, RAG allows LLMs to access, retrieve, and use up-to-date information from external databases before generating responses. Right. So the idea is basically it is helping us understand about, again, are you guys able to hear me, all of you? Can you quickly confirm? Okay. All right. So basically, the biggest problem which large language model has is training, right? Training takes a lot of time. And if anything is changing, right? For example, I want to train on the new data. So training will be a cost as well. So without doing that external training quite frequently, can we have some solution which can help me to go ahead and give me the latest information as well? So the idea here is RAG is one of the solutions which is helping me to do the same, right? Here is the typical RAG architecture which we have. Here you can see that we have a document, right? The main purpose of RAG is how can I access the external data source? For example, let's say I'm working for one company and how I can use that company's document and help with the LLM get the responses from the same. For example, I am having a policy document, HR policy document, and I want to get the responses from that document. For example, let's say I want to know how many leaves are there, right? Or how many leaves I can take per year. So those type of questions I can very well get as a response when I am using this type of RAG architecture, right? So let's try to understand this flow first. So we have loaded the document in our system. The first step after loading the document will be splitting the document, because every LLM has its own context length and I cannot process the huge amount of document. So we have to chunk it, right? We have to split it. There are various different ways to do the splitting. So we have to first split the data, right? So a big document will be split into multiple parts. Once that is done, I will be converting this split into embeddings. Embeddings are basically nothing but converting the textual data to numbers, right? To a vectors. So there are various models which are available. OpenAI also has its own model. Other companies are also having their own embedding models, which is helping me to convert the text to numbers. So I will convert that to numbers. And once that is done, I'll be loading that to this database. This is a special database, which is helping us to store the vectors. And vectors are nothing but like a set of numbers. This type of database is known as vector database, right? There are various companies which are giving that option. Pinecone is one company which is having its own vector database. ChromaDB is there. Milvus is there, and like there are various other vector databases are available. Once the entire document is converted to numbers, I will store that in this database. After that, user asks any query. For example, let's say this document is your HR document and it has all the policy specific details. User is asking one query that how many leaves I can take per year. So this user query will be converted to numbers. You can see here, it's converting to embedding, input embedding. And then searching will happen on this vector database, right? I'll show you how the internally things happen with one simple example in some time. But I will search this input vector with the vectors which are available in the vector database. Whichever vectors are near, I will go ahead and I'll pick those documents. I'll pick those vectors and put it in the system query. Your user query is also going back. So user query plus the fetched out vectors, those are getting inside the AI, that is your LLM. And based on that, the response is coming in. User query was what? How many leaves I can take per year? And these are the pages which are having that information because it is doing a semantic search. And from that search, it is giving me the relevant pages and those pages are picked up. So now LLM will have the user query plus the relevant responses as well. And with the combination of this, it is generating the outcome, right? And that is what the core idea of RAG. And how this happened, like why or how this idea came in, right? So let's try to understand this. So I'll open ChatGPT. Just give me a second. Yeah. So there is a concept of few short prompting. For example, I am saying 1 plus 1 is 2, 3 plus 4 is 7. Now I want 5 plus 8. So basically what happens, it will going to give me this type of response. So I gave few example, right? And based on that, machine is giving me the response. So that is the idea. And this is a few short prompting, right? So that is what the concept they found out in GPT 3.5 and above, that machine has that capability to, if I give a certain context and from that context, I can get the response as well. And that is what happening here as well. Your pages plus user query will be acting like a context, right? And combining both together, it is going to give me the response. So that was the core idea which they found out, that this is what happening and that was the behavior. And based on that behavior, they have decided of coming up with the RAG concept. The benefit of RAG is that it is cheaper. I don't have to train my model again and again, right? Because every time if a new data comes in, I cannot train it, right? It requires a lot of energy, and for that we need good amount of gap as well. Second is, if a latest information coming in and I wanted to know more about that, so I can plug and play. I can plug those latest information with my LLM with the help of RAG, and then I can ask questions based on that, right? So those are the benefits which we are getting, and that's why RAG is one of the very powerful concepts coming in. And I can very well say that it came in with accident, right? It was an accident invention, and now people are using it quite extensively, right? So that is one of the very interesting concept. Now let me give you the idea how things happen. Let's take a scenario here. So I have three diseases, right? Asthma, COVID, and cancer. These are the three diseases available in my document. Here you can see a vector representation of three vectors. V1 is talking about asthma. V2 is talking about COVID-19 and V3 is talking about your cancer, right? Now, user is asking one question, tell me about COVID-19. So here you can see that this is my input vector IV and it is more closer to V2, right? Why or how it is getting closer and all, we'll discuss the mathematical quick discussion as well. But it is more closer to V2. So now what machine will do, it will pick up the closest vector and give me the response. So as the closer vector is COVID-19, it will give me the response based on this text. That is the core and the overview of the semantic search, right? Here is an example how it works. Here you can see there are three sentences. I love data science, I love data analysis, I love Java programming. I can clearly say that I love data science and I love data analysis both are more closer as compared to I love Java programming. So here you can see that I created a vector where I have I love. This is like one what do you say, bag of word type of concept I am using. Although people are using now embedding models and all, but just to make it simple for you to understand, this is how my vector represented. It's a 7-dimension vector. I love data science are ones, rest all are zero. I love data analysis is ones, rest all are zero. I love Java programming are ones, rest all are zero. Right. Now I will be doing the calculation, that is A dot B upon length of A into length of B. That is going to give me the cosine similarity. A dot B is nothing but A1 into B1 plus A2 into B2 plus A2 into B3, A4 into B4, A5 into B5, A6 into B6, A7 into B7. Same I will be doing with first vector and the second vector, first vector and the third vector, second vector and the third vector. And I will be calculating the cosine similarity, right? Bigger the value I will have, you can see here the values are more towards 1. The angle between the two vectors are 0. That means they are more closer, right? So if you do the math behind this, you will see that this plus this, the combination of A and B will give me the bigger value. Combination of A and C will give me the smaller value. Combination of B and C will also giving me the smaller value. So as A and B are giving me the higher value, that means the angle between A and B is smaller. And as they are smaller, that means they are more closer, right? So you can try from your side. It is simple mathematics, right? A1 into B1 plus A2 into B2, A2 into B3. Same way A1 into C1, B1 into C1, and so on. Length of A is nothing but a distance of the vector from the origin. Length of B is what? A distance of a vector from the origin, right? So when you do the calculation, I think the value between A and B will be coming out to be something like 0.75, and value between A and C and B and C will be coming out around 0.5. So 0.75 is bigger than 0.5. That means A and B are more closer, right? So that is the idea that is going on behind the calculations, which is your similarity search. And based on that, it is going to give me the response. Okay. So that is the concept. Now, the core component of RAG is document processing, right? For example, I am having a PDF file. I will go ahead and I will load that PDF file. Once I load that PDF file, after that, I will be going ahead and converting that to a vector, right? Converting that to the set of numbers. I will have a retriever as well. If you go back to this picture, right, which I have shown you. So this part is a retriever. I am going and putting the input embedding, and from this vector store, I am retrieving the information, right? So this is my retriever. So this is my document loader where I am loading the document. This is your embedding, splitting and embedding, right? So splitting is happening, then embedding is happening. Then this vector store is coming in where I'm storing this entire vector. User query is coming in and it will help me to retrieve the relevant information and going to the system query. User query plus your fetched out vectors combined together, going to your LLM and then the response coming in. So that is what it's mentioned here as well, the overview of the core components of RAG. So document processing, converting document into embeddings for efficient retrieval. Vector database, storing embedded documents in searchable format. Retriever is finding relevant documents based on query similarity. Generator is creating accurate responses using retrieved context, right? So that is your core component of RAG. There are various use cases where we can apply RAG. When you need factual accuracy beyond LLM's training data, when working with domain specific or proprietary information, when information needs to be up to date and verifiable, when transparency and citation of sources matters, when you need to reduce hallucinations in LLM output. For example, let's say I'm having a chatbot and I'm offering a lot of products, right? So if any user comes in and user wants to know that what type of products I am selling, so I'll be having one document which consists of all the information about the products. I will create a chatbot based on that, right? So all the document will be going inside the system as a vector, and then user will ask any question that what all products you are offering. It will hit that document, fetch out the information, and give me the response, right? So we can actually use the company's documents and fetched out the information. Chatbot is one of the use cases which you can have. There are different types of RAGs are there. Standard RAG is there, corrective RAG is there, speculative RAG, fusion RAG, agentic RAG is there, right? Self RAG is there, hierarchical RAG is there, multimodal RAG is there, adaptive RAG is there, and fine-tuned RAG is there. So different variant of RAGs are available. Although in this particular discussion, we are focusing only on the basic RAG system, but I'll give this presentation. You can go through that and you can basically uh, go through that and you can explore from your side. Or we are planning to have more sessions on these topics, so you can join that later on. So best practices of RAG implementation. So document processing, balance semantic coherence and retrieval granularity. Chunk size, basically I am breaking the document into chunks, right? So we can have a chunk size between 256 to 1024 tokens. There should be an overlap because no context I want to miss, right? So if I am breaking a document, I will have in every chunk, there will be some overlaps, right? So that will take care of the uh, context of one chunk from the second chunk, right? Embedding selection, you can use various different models for embedding. Embedding is nothing but converting the data into numbers. So you can use OpenAI model and all those things. I'm going to use OpenAI today. We can create higher dimension space. So at the time of embedding creation, we can define that how many dimensions of vector we can create, right? So that we can define. And it's again a thumb rule that if the information which I want to store is not huge, then I will not go with the huge vector size. I will go with a smaller vector size. And if the information which I want to store is huge, in that case, I may go with huge vector size as well. We have a retrieval strategy. We can retrieve the top K selection. There is an option of choosing that how many relevant documents you want to fetch out. I can decide that, okay, I want only 3 documents which are relevant. If let's say there are 10 relevant documents, but I only want top 3 relevant documents and give me the response from that. So that type of thing we can do. And then prompt is again very important aspect of your RAG system because the entire context which is fetched out from the document plus the user query, it will combine together and then the response will be coming in. So that combining is happening at the prompt level. There are common challenges which you may face while implementing the RAG solutions like hallucinations, implement fact checkings and source validation. Whenever you are creating a RAG model, right, or you can say RAG system, you have to make sure that your system is pretty much working fine. You have to do a proper testing as well. There is a retrieval latency problem is there that your output is coming a bit slower, right? So you have to just fine tune that as well. There can be a context length limit, right? Every model has its own context length. So we can check it out whether it is not crossing the context length. Irrelevant retrieval, add filtering and pre-processing of document so that will not get the irrelevant retrievals from the document. If I'm asking about the how many holidays I can take or how many leaves I can take, then it should give me only those relevant information. It should not give me something else, right? These are some of the numbers which people are looking forward to at in the industry. Around 85% answer relevance, 95% factual accuracy, and 80% retrieval precision. The real world use cases which you can have in your companies, you can try to implement can be enterprise knowledge base. I'll going to show you one example today where I will have the HR policy small document and I'll create a rack system, right? Basically, the code is ready. I'll just quickly go through that. So enterprise knowledge base, customer support, we can create research assistant, we can create educational tutoring, we can create compliance monitoring, we can create. So rack systems are transforming how organizations leverage AI by combining the power of large language models with accurate, up-to-date information retrieval. And we can start with a standard rack and slowly we can expand it and make it more sophisticated architectures, right? As you grow further. So with that, let's take one example so that we'll get the idea also. This will work. I'll share this PPT, don't worry. So here is the code which I have created, right? So I'll first show you the document which we are going to have. So this is the data folder where I have created one dummy document which has all the employee specific information, right? So what will be the office timings, leave policy, work from home policy, dress code, code of conduct, IT and security policy, probation and confirmation, performance appraisal, learning and development, emergency contacts, right? So this is the document which I want to put it in my system. And once I do that, after that, I will ask questions in the natural language and it will hit the vector database and it is going to give me the response from the vector database, right? That is the flow. So parallelly try to understand this. So if I go back to the PPT, so we are at this level as of now. So we are at this point. I have a document, right? And I want to upload that document in my system. Now there are various frameworks available for you to build this type of applications. I'm using one of the very powerful package, although everything is at it's very new. Everything is very new and people are exploring it. People are updating it quite extensively. But one of the packages which is like since the LLM came in, since that time, this package is there. People started building this package is known as LangChain, right? So LangChain, and now they have come up with a upgraded version, or I can say a more powerful package called LangGraph, right? So in this particular session, I will be using LangChain. I'll be creating the solution using LangChain. LangChain has its own website where you can go ahead and you can ask your you can go ahead and you can ask your doubts, right? You can go to the website and you can see all the relevant documents about LangChain. And if you are planning to explore LangChain from your side, then that website will help you quite extensively. You can go and you can check it out as well if you go to the internet. Show you. LangChain. So here you can see this is the official website and it has various products, LangChain, LangGraph. So LangGraph is more sophisticated, and if you want to create very powerful agents or agentic AI system, then LangGraph is what you can use. But if you want to create a single flow type of applications or workflows, right? In that case, LangChain can be a good option. I'll be using this OpenAI API key for embedding model and for your this thing, right? Generation of the response. So I already have this key with me and I'm using that. So here you can see that this is, we already have seen the document. Now here is my first code, which is ingest.py. I'll share these codes as well for your reference. So here you can see that I'm using the document loader, right? If you go back to the PPT, I told you that this is my document loader, which is helping me to load the document, right? After that, what we are expecting? We are expecting the splitting, right? So if you go back to your code, so once you can see we have a splitter as well, which is helping me to split the document. Vector store is also there, which will help me to store the vectors, right? So let's go and below and let's see what's happening. So here I have loaded the relevant modules which I want for my application. You can see ChromaDB is also there, which I am using. I told you there are different databases are available. Pinecone is one of the databases. Your ChromaDB is one of the databases. Your Milvus is one of the databases. FAISS from Facebook is also one of the vector store. So those are the options which are available, which you can use. So here you can see we are loading the environment file. So this is my environment file where my API key is present. So this is my API key coming from OpenAI. It's a paid thing. Basically, it's something like a prepaid type of concept. As per the usage, they will charge, right? If you want the key, you can create your account in this website, platform.openai.com, and you can recharge, right? You can have the billing and you can set your account and then you can recharge that, right? So I recharge with $12. You can put $5 and you can use it for quite good amount of time, right? So you can, if you want to practice, then you can very well use this. So once that is done, here you can see I am giving the path of my file, that is your employee handbook. After that, we are having the ChromaDB, which is I am creating a database. Here you can see that ChromaDB coming in, chroma_db, right? I already ran this code so that it will not fail in the class. So ChromaDB database got created. Employee handbook, I'll run this again. So employee handbook is my file name, which I just have shown you, employee handbook. So we are giving the collection name as employee handbook. You can consider it something like a table, right? So in the ChromaDB, I am creating one table called employee handbook, where I'll be storing this entire PDF as a number. Next, we are loading the PDF file. So you can see this is my document loader, py PDF. Here you can see that, right? This is what we imported, document loader, py PDF loader. So that is what I am using here, py PDF loader, and I am giving the path of my file, which I want to read. Once I load it, my data loaded successfully. After that, I am using the splitter, right? That is your recursive character text splitter. So that is again one way of splitting. Again, there are different ways of splitting. Splitters are available. This is one way of splitting technique which we have, which I am using as of now. The chunk size I want is 800. That means if let's say my document has 8,000 words, right? 8,000 tokens, for example. So I'll be breaking this particular document into 10 parts, 800 per chunk, right? But now there is one more thing, but I am giving one overlap also, right? So overlap is what? We have 800 words or 800 tokens. As of now, for simplicity's sake, let's call it as words. So we have 800 words in one chunk. Now in the next chunk, I will have 650 words plus 150 words from the previous chunk, right? So that is known as overlap chunk. So this way we will be creating around 10, 15, 10 to 12 chunks, right? Because we'll have 150 overlaps as well. So I'm using the splitter and splitting the document into chunks. It will give me the length of chunk as well, how many chunks got created based on your document size. Once that is done, we are calling the OpenAI embeddings. So basically, if you see here, we have this OpenAI LangChain_OpenAI embeddings, which I have imported. So I'm using this OpenAI embeddings out here. And the model which I'm using is text embedding 3 small, right? So if you go to the OpenAI website, you will be seeing a lot of different models which are available for embedding. Embedding is basically nothing but converting the text to numbers. So OpenAI embedding model. So here you can see there are three models which are available. One is small, second is large, and there is one more model which is ADA. Right, you will find somewhere here. Yeah. So here you can see small, large, and ADA. So these are the different models. I am using small for now, and this is what we are using here. Okay, so that is my embedding model. Now after that, what will happen? So embedding is there. You can see I'm calling this embedding here, right? Embedding is one variable which I created, and I am calling this embedding here. Chunks are nothing but your chunks which you created from your splitter. Those chunks you are passing here, passing the embedding model. You want to store in the persistent directory and you want to store in the collection. What is the persistent directory? Persistent directory is ChromaDB. You can see here I have mentioned somewhere. Persistent directory is nothing but ChromaDB. And what is my collection? My collection is employee handbook. So basically in my ChromaDB database, there is a table called employee handbook. Your embedded output is going inside that table collection, right? So here my vector store got created. Once that is done, this part is basically only for creating the vector store, right? So if I come back to the PPT, this part is done up till this part, right? Document loading, splitting, embedding, and vector store. So up till this part, we are done with. Okay, so let me run that code. So now when I go and I execute this, so the database is already created, it will just overwrite it. So here you can see that it created 5 chunks, right? Based on the document which we have. Loaded 2 pages because in my PDF there were 2 pages only. So it loaded 2 pages, created 5 chunks, and your vector store is created. Once that is done, once my vector store is ready, now I'll be going to my ask.py. And here again, I am using OpenAI, but this time I am using the OpenAI chat OpenAI model and OpenAI embedding model as well, right? What is embedding model? Converting the text into numbers, right? Which I have used here as well because I wanted to convert my PDF file to numbers. So there I used this OpenAI embedding, right? Why are we using OpenAI embedding here? You can very well answer if you see this PPT that when user is passing a query, I want to convert that to embedding as well, right? Till the time I am not converting this to an embedding, how will I compare with my vectors which I have stored in the vector store? Okay. So that is the reason I have to use, I'll share this code. Okay. So OpenAI embedding and chat OpenAI. Why we need chat OpenAI? We need chat OpenAI because of this guy, this one, right? This LLM. This LLM is, there are two types of LLMs, right? One is converting text to numbers. So text to numbers are the embedding models and text to text, right? So that is nothing but your chat models. So I need this chat models, which will help me to give me the text responses. So that's why this chat OpenAI is required, right? Which is going to generate the text. Vector store, again, I need because I'm going to compare that with, so that I'm calling here, right? I need this vector store. Chat prompt template, which will help me to generate the prompt for output coming from your vector store. Based on that, it will generate the entire prompt. Create stuff document chain. So basically, it will help me to combine the documents. Create retrieval chain, which will help me to retrieve the relevant information from the vector store. So here you can see that we have the databases coming in, embedding coming in, OpenAI embedding, right? Again, ChromaDB calling the embedding here, vector store, reconnecting the same ChromaDB. After that, we have a retriever, vector db dot as retriever search k equal to 4. What is k equal to 4? It is saying that I want the top 4 relevant documents, right? I may have a lot of things about, let's say, leave policies. But what is my interest? My interest is I want only top 4 documents. Okay. So that is one thing. Then we are calling the LLM chat OpenAI model GPT-4o mini temperature equal to 0. Then here is my prompt template. You are a helpful assistant. Answer only using the information in the context. If the answer is not in the context, say you don't know, right? Human, context, and answer concisely, right? Here is my document chain where it's calling my LLM and the prompt. Here is my RAG chain where I have the retriever and the doc chain, right? Doc chain is coming from the previous. So basically what is happening, your prompt will have the entire information, question and the context, which is going in the document chain. And that document chain will be part of this RAG chain where retriever plus document chain coming in. And then it will respond as a RAG chain. Then here you can see we are building the RAG system invoking the question which user is asking. And based on that, it will generate the response based on your context, right? And then here you can see some of the questions will be coming in. Let me run this code. Let's see what's happening. So I'll execute this. So again, it will rebuild your vector store. And here you can see that first question was what? What are the official office timings and lunch break, right? So here you can see that office timing 9 a.m. to 6 p.m. Monday to Friday. Let's go and let's compare that with our original document. So here you can see office timing 9 a.m. to 6 p.m. Lunch break is 1 p.m. to 2 p.m. right? And if you go and check it out, lunch break is 1 p.m. to 2 p.m. Login expectation, employee should be logged in by 9:30 a.m. right? So if you go back and check your document again, so logged in by 9:30 a.m. right? So that is pretty much okay. Let me close this for now. Let me put this side by side. Okay. Next is how many paid leaves do we get per year and how carry forward works, right? So let's see that. First of all, let's read the response from the RAG system, then we'll compare it here. Employees are entitled to get 18 paid leaves annually. This includes 12 casual leaves, sick leaves, and 6 privileged. Unused leaves can be carried forward up to maximum of 30 days, right? So let's go and check in the leave policy. 18 paid leaves, 12 casual leaves, and 30 is carry forward maximum, right? So that information is also correct. How many work from home coming in, right? So here you can see work from home. So you can read this and you can compare with this. 5 work from home, 5 work from home. It is looking perfectly fine, right? And same way, whom to contact during emergencies. So phone number coming in, and that is the phone number here also present, 987654, right? So that is how it is responding. Also, I created one front end as well. So basically, this is all the backend part. And I wanted to showcase that in a front end also. For example, I want to showcase to the client that this type of document this type of RAG system I can build, which will help me to fetch out the relevant information from the document. So for the demo purpose, you can create one demo with the help of package called Streamlit. So Streamlit is one of the packages which is helping me to create the front end in Python, right? So here again, all the same things, right? Splitter, document loader, all those things I'm importing, having the RAG, Chroma DB. This is a separate code altogether, right? So there is no relation of this and this. This is a separate code which I have created, where again everything will happen: loading the document, splitting the document, vector store, right? Connect to the vector store, creating the RAG chain. Then again, this is the entire front end part. So now when I run this code, so it will open up the web browser. It's open up in my second screen. So here you can see, this is my web browser coming in. RAG over your PDF. This is again just a dummy which I have created. You can make it more visually appealing as well, right? Here you can see there is an option of calling the PDF file, right? So I'll just browse it and I will choose my employee handbook PDF. Once that is done, once the file is loaded, now I'll be clicking on this build/rebuild index, right? Chunk size, overlap size, all those things I can set. So I click on this and automatically you can see the document loaded, splitting, chunk created, all those things happened and my index is ready. So basically this is the front end where I am generating the vector store directly. So my vector store got created. Now I can ask any random question here, right? For example, let's say, what is the office timing? It's already a default question. So when I click on that, so here you can see that it is going to give me the response. Office timing is 9 to 6. Employee should be logged in by 9:30 a.m. and lunch break is 1 to 2 p.m. Right? And it is also giving me the reference that from which page number you got this information. Right? So all those information coming in. Suppose I am asking any random question which is not present in the document. Right? For example, how can I report uh, something, right? Maybe about issues. Maybe it will go to emergency. Let's see, right? Issues related to my office politics, right? So let's run this. It may not give me the response, right? Let's see what happens. To report issue related to office politics, you should follow company code of conduct. So now here you can see that this is a hallucinated response. I don't think it is present in my document. Let me just go to the document. Basically, it is mocking up, I guess. I'm not sure. I need to check that. Dress code, code of conduct, right? Okay, it is there, right? So it is taking from this. All employees must contain a respectful, inclusive, and collaborative work environment. Let's see what it is responding. Conduct inclusive environment. Yeah, it is taking from that only. So which is good, which is fine. I want to ask something which is like not there. Maybe where will I get the employee information? Employee information can be found in employee handbook. Again, this is just a generic response coming in. Who is the PM of India? Now here we did not mention about that. Don't give me the response, right? Let's see first of all what is coming in. Yeah, so this is fine, right? I don't know. Now why it is not responding? Because we have explicitly mentioned out there. If you go to the code, where is the code? Yeah. Here in the context, if you see, you are a helpful assistant. Answer only using the information in the context, right? So basically your RAG will fetch out the relevant document and your machine will give me the response only based on that document. That's why when I'm saying that who is the Prime Minister of India, it is not giving me the response, right? If the answer is not about the context, say you don't know, right? So that is the reason the output is not coming in. But here if I change it, for example, let's say I go and I say answer only if the information is in the context. If the answer is not in the context, access the internet, right? Access the internet and get the response. So now here I'm explicitly mentioning that you access the internet. Let's see what happens. I'll rerun this. So let me rerun this. And now I'm asking the same thing again. Now let me first load this file again. Let me recreate my embedding. Who is the PM of India? So here you can see the context provided does not contain information about the Prime Minister of India. Please check reliable sources for current Prime Minister of India name, right? So it's not giving me the response still, right? That is fine. So we may have to fine tune this code further and we have to add. So there is one more concept called tools in LangChain. So we may have to add one tool where I can say that you access the internet, right? It is not accessing the internet directly. So that's the reason it's not coming in. Maybe I can play around with the prompt and I can try to get the response. Your helpful assistant answer only using the information in the context. This line, maybe it's not properly taken by the machine. So in this line only, we have to do some more changes, right? Or we can add the tool as well. So basically, when we are creating an agents, we can ask for the tool. So what happens is that agent will check it out. That if if the like basically when I'm asking certain things, agent will check what all tools are available for agent to access, right? So we can have one tool where we can mention that we can access the internet also, and it will hit the internet and give me the response. Okay. So that is the idea. But let me try to make a change out here again. Let's see what happens. Let me make a minor change here. You have to answer question based on the context. And if the context does not have the information, you can access the internet and give the response. Right. So let's save it. So here you can see a minor change in the context gave me this option, right? The context provided does not contain information about the Prime Minister of India. However, as of my last knowledge update, it is now accessing the internet, right? Internet as in, or I can say not internet rather, because it is only accessing the knowledge, right? Rather than internet, I can mention something like this: use your knowledge, right? Because directly internet access will be not happening here. You may have to give the tool access, right? So that was I was talking about. I can say that you can access your knowledge. You can access your knowledge and give the response. This will be the correct prompt. Now let's refresh again. Okay, so here you can see Narendra Modi coming in. So that is how we can add the external as well. So here I created the standard rack, but I gave an access to the knowledge of the machine as well, right? So you can see that just a minor change in the prompt, and now it is accessing the knowledge from itself as well. Or if you don't want to restrict that, change the prompt, say that only give the response from the context, nothing else, right? So that type of thing also we can do. So this is what I wanted to cover. I hope you got something new here. I'll share these codes and PPT with the support team. They will share it with you, right? Any doubts, any queries you have, you can let me know. It was a basic understanding, right? If you like the session, then we may plan to have more sessions like this where we'll dig down further, right? This was like I wanted to give you a very high overview of the concept, right? And if you want, we can have more sessions like this where we can uh, write code as well, right? So it's like a we can have something like a playlist type of concept, right? So where we can have first session talking about something, second session further adding up something like that. Okay, cool. So I hope you enjoyed. We'll see you in the next session. Any doubts you guys have, you can let me know. For non-coders, how easy to build RAG models? See, if you want to create a RAG model without coding, there are tools available like N8N, Zapier. These are some of the tools which are available where the coding is very less. You can just drag and drop and you can create the RAG systems as well, right? And if obviously if you are aware of Python, then creating the solution will not be a challenge. Any way of creating RAG model using prompt? You cannot give the entire document, right? So document can be very big and every LLM has its own context length. So if you are giving entire document and creating the RAG, it will not run properly because OpenAI models can only remember 128,000 tokens, right? So that's the reason. Uh, when the document size will be higher or bigger, in that case, directly from the prompt, it may not give me the response. That's why we need this entire architecture. I'll share the documents with the support team and they will forward it to you guys. We already have the details. We'll send it. Alright, so we'll see you in the next session. Till then, take care and have a nice day.